So today we start talking about factoring. Okay? Last week we did what?
We did division.
Division, adding,
subtracting,
subtracting, multiplying, right? Those are the things that we did last week. We did the major operations with polynomials, right? Okay? What I need you to understand about factoring is very, very, very similar to dividing. It's not like long division, it's not like synthetic division, but to factor something means you're taking it down to its parts. You're dividing it into its parts. Does that make sense? Okay? And so, there's a lot of different ways to factor, first of all. Okay? Today we're going to talk about some special cases, and tomorrow we'll get into the meat of the factoring. Okay, of the things that you most often see when you're factoring. But today we need to look at very special cases. Okay, now this one's not a special case, but we can't really start talking about anything until we talk about greatest common factor. Okay, GCF is greatest common factor. What do you think I want you to do if we're trying to factor out the greatest common factor? Well, first of all, here's what a problem would look like. Just a real simple, basic problem. 2x plus 6. What do you notice about both of those terms in the problem?
They both can divide into 6.
They're both divisible by 2, right? So if I factor out a 2, if I divide each term by 2, what's left? What's this term divided by 2? X. What's this term divided by 2? 3. And then I'm done. Yep. Now, is it always going to be the answer? No. Sometimes I need to go on and do something else, right? Sometimes it'll combine with some of these other things that we're going to talk about today. But very first, on every problem that we need to do, we need to check to see if there's greatest common factor. Okay? Because notice when I take out a greatest common factor, what does it make this? It makes it easier, doesn't it? Makes it smaller. Okay? So what if the problem looked like this? 4x to the 5th minus 10x to the 3rd. Well, what do you notice about these numbers, first of all? Let's talk about the coefficients, the numbers. They are both divisible by 2. Okay? Now, what else do you notice? They both have an x, right? So I have to figure out the biggest, right, the greatest common x that they have. But I'll tell you this, the greatest common x is going to be the smallest x, isn't it? Okay? I don't want you to think I can divide an x to the 5th, because it's the greatest, out of each term. Because can I divide x to the 3rd by x to the 5th? I can't divide a bigger thing from a smaller thing, can I? Okay? So what is the smallest exponent here then? So that is going to be my greatest common factor. And that gets people sometimes, because the greatest common factor is actually the smallest exponent. Does that make sense? Okay. What's left if I divide this first term by 2? First of all, what do I have left? 2. What's left if I divide x to the 5th by x to the 3rd? It is, right? It's x squared, because if I'm dividing exponents, what do I do? If I'm dividing like bases, what do I do with the exponents? Subtract, right? What is 5 minus 3? 2. You okay with that? Now, look here. What is 10 divided by 2? 5. And then what's x to the 3rd divided by x to the 3rd? What's anything divided by itself? Except for 0, right? It's always 1. So it's just that. That's all we got. Does that make sense? So every problem that we do today, we're going to make sure to look for the greatest common factor first. That'll make things a lot easier for us. Okay? All right, so the first special case that we can finally get to is called the difference of squares. Would you write that down for me, please? Difference of squares. So what do you think I mean by this vocabulary? What does this word mean? Subtract, right? Difference means subtract. And what do you think I mean by this term? Do you think I mean like geometry squares? No. Can you give me an example of a square? 4, 9, 16, 25, 36. What? A number that I can take the square root of, right? That's called a squared number. So the difference of squares is going to look something like this. 4x squared minus 9. Because 4 is a squared number, x squared is a squared number, and 9 is a squared number. And it's the difference of these two squared numbers. Does that make sense? This is something you need to be able to recognize. That is the difference of squares. Does that make sense? Now, there's formulas that I can make you memorize for this. I don't, because I don't teach you formulas for this. I'm going to teach you patterns, and people are almost always better able to recognize or remember a pattern than they are to memorize a formula. Does that make sense? Okay, so when I factor the difference of squares, what I end up with is two binomials. Okay, you don't have to draw the lines if you don't want to. I'm just making sure you understand it as two binomials. Does that make sense? So the very beginning of each binomial is going to be the same thing. And we take the first term of the problem and we square root it. What is the square root of 4x squared? Well, what's the square root of 4? 2. And what's the square root of x squared? Right? What times itself equals x squared? X. So 2x goes here and 2x goes here. It goes at the beginning of each binomial. Does that make sense? Now, what do you think is going to go at the back of each binomial? 3. Where do you think that came from? The square root of 9, right? So 3 here and 3 here. All that's left to fill in is what? The signs. They just have to be opposite. So if I have a problem of 4x squared minus 9, I square root the first term, square root the second term, and make sure my signs are opposite. Does that make sense? Yes, sir?
Does it matter which way you put them?
That's a good question. Can I address it in the next example?
Yes, ma'am.
Perfect. Thank you. Any questions on this example? Okay. What about this? 50y squared minus 32x squared. Is this the difference of squares? No, it's not, is it? Like, what times itself equals 50? Nothing, right? But what do you notice about these two numbers? They're both even. So what does that mean? They're divisible by 2. What if I factor out a 2 from each term? What do I have left? What's this? 25y squared. And what's this one? Yep, 16x squared. Now, what do you notice about these two numbers? They are squares, aren't they? Okay, so what do I do with this 2? I just drag it along, right? Nothing I can really do with it now, but I do need my two binomials. Okay, two binomials. What goes at the beginning of each binomial? 5y. Very good. What goes at the end of each binomial? 4x. And to answer his question from a second ago, look what I did with the signs. Is it some magic thing? What did I tell you the signs have to be? Opposite. Does it matter if the minus comes first or the plus comes first? And it does not, because it doesn't matter what order we multiply in, does it? It doesn't matter if I multiply this one with the x first times this, or with the minus first times this one with the plus second, or if I multiply this one with the plus first and this one with the minus second. Okay, so does it matter which sign goes where? No, as long as they are opposite. Okay? Any questions about that? So what about this? Sum of squares. What's that going to look like? So exactly like it just looked like, except I'm adding. So like this.
Yeah.
This is going to be your favorite one. No, I promise. It'll be your favorite one. What? Actually, it's my favorite one. You know why?
Why?
Because it's done. We can't do anything with it.
Yay. What?
At Algebra 2 level, we cannot factor the sum of squares.
Heck yeah. Why? So I do worksheet on these.
Think about this. Think about this real quick. I'm going to go back up to this one, right? If I took these two answers and multiplied them together, I would distribute, right? 2x times 2x equals what? 4x squared. 2x times 3 equals what? 6x. Negative 3 times 2x equals what? Negative 6x. So what happens with the positive 6x and negative 6x?
Cancels out.
It goes to 0. And then I have a negative 3 times positive 3, which equals what? Negative 9. So because they're opposite signs, the middle term goes to 0, right? If we're thinking that same way here, my signs have to be opposite so that the middle terms will go to 0, right? That means when I multiply this times this, can I ever